Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with chemistry spectroscopy. This is the chapter on IR spectra and this is lecture number 4. I will explain you what is IR spectra in this lecture. Okay. So basically infrared is radiation, electromagnetic radiation, light. And we have different units to measure the light, and that is wavelength, for that we keep lambda, and the unit can be angstrom, nanometer, etc., centimeter, etc. Okay, and the relation between micron and centimeter is 1 micron is equal to 10 raised to minus 4 centimeter. Second unit or second parameter which we use to measure light is frequency. The symbol is nu, and nu is equal to c upon lambda. Okay, and c is velocity of light, lambda is wavelength, and the unit of frequency will be hertz or second inverse. Okay, so it can be in hertz or second inverse. Next is wave number, which is very important for us. Sometimes it is also referred as frequency, but it is not actually frequency. The symbol is nu bar, which is equal to 1 upon lambda. See, this is the difference between frequency and wave number, and therefore the unit will be centimeter inverse. Now, wave number will be given in centimeter inverse or in micron also, and the relation between micron and wave number is this one, that wave number is equal to 1 upon micron in times 10 raised to 4 centimeter inverse. Okay, so here we will put this way, that if it is 2 micron, then which is equal to 5000 centimeter inverse. 5 microns equals to 2000 centimeter inverse. 10 micron equals to 1000 centimeter inverse, and 15 microns equals to about 660 centimeter inverse. So our range of infrared is 2 micron to 15 micron, or 4000 centimeter inverse to 660 centimeter inverse. Okay, now we will draw graph of infrared spectra. On x-axis we will have frequency or wave number, which will be in centimeter inverse, and the range is from 4000 centimeter inverse to 660 centimeter inverse. Okay, normally graph is always a peak, but in infrared it is not a peak. Okay, in infrared we observe dips like this, so we go down. Okay, and on y-axis we put percentage transmittance. So it is percentage transmittance. If it is 100%, the line goes here on x-axis with y-axis equal to 0. Okay, or it can be minimum 0%. If 0% transmittance, then it will reach here. It depends on absorption of radiations. Okay, and the mode of graph is like this. You will observe this one. like this. Okay, so there are various kinds of bands. These are called bands or dips and sometimes referred as peaks also. Okay, the nature of peaks or dips or bands are different. Here we will try to split this graph into two different categories. One is this one, from this one, where you will find many dips, okay, and it is known as fingerprint region, in which you find many dips or bands, okay, and it start between 1500 to 660 centimeter inverse, which is called fingerprint region, and the rest on the left hand side, this one, which is very important part, which we called functional group region, in which we will have very specific numbers of bands or dips appear in this region. Okay, so we can identify the presence of certain functional group from this part. Okay, fingerprint will be difficult to interpret, but still there are certain locations in this case which are very identical. Okay, so this is regarding the graph which we observe in infrared spectra. Okay, now here I will explain you different types of uh, dips and bands present in a given infrared spectra. So there are various types of dips or bands. First of all, let us see this one, where you will see this type of broad band. So it is called broadband. Normally broadband appear because of the interaction of functional group with others. With reference to this, we have another type of band which is like this, and it is called sharp band. Okay, so sharp bands are like this, and this shows the absence of interaction of functional group with others. Now, there are three different types of bands. Normally, I will explain you this one. That those bands are like this, very small, okay, and their presence is, or their percentage transmittance is between 100% to 80%, or absorption is maximum 20%. This type of bands are known as weak bands. For this we use the abbreviation W. Okay. Next we will see bands are like this. So here percentage transmittance will be between 60% to 40%, or absorption is between 40 to 60%. These are known as medium bands. For that we use M, small m in abbreviations. Next could be this type of huge bands, okay, where percentage transmittance would be greater than 80%. Okay, and they are called strong bands. And for strong bands we use S. Remember, for sharp bands we use SH. Okay, and for broad band we will use BR. But for strong bands we use S. So there will be normally either weak bands, medium bands, or strong bands appear in IR spectra. Okay, so this is about IR spectra. That's it in this lecture. Thank you so much.